Hi students, once again I welcome you all to my channel Abrar Sir Classes. Today we'll be learning an important topic called LCR Series Circuit. Now this is a LCR Series Circuit in which L, C and R are connected in series. Let us say the current is given by I is equal to I naught sine of omega t. This is the current of the voltage source. Okay, now this current is flowing here, okay, in all the three elements of the circuit, that is L, C and R. Okay, what is VL? VL is the voltage across L, VC is the voltage across C, VR is the voltage across R. Now here what is XL? XL will be equal to what? Omega L. What is XC? XC will be equal to what? 1 by omega C, and this is R is the resistance. Now here if you take current as a reference in the x-axis, okay, if you take current as reference in the x-axis, how to draw the phasor diagram? Okay, that is the phasor diagram. If you write, okay, you can write like this. This is current I, and here in case of inductor, voltage will be leading, current is lagging. This is VL, right? Okay, this will be, voltage will be leading by an angle pi by 2, right? In case of capacitor, voltage will be lagging by an angle how much? Pi by 2, pi by 2. Okay, in case of resistor, if this is the current, okay, voltage will be in phase. Both voltage and current are in phase. Here current is leading in case of capacitor and voltage is leading in case of inductor. Now if I want to write voltage phasor diagram, how to write the voltage phasor diagram for a series LCR circuit? This is current I. If I take current as reference, this is what? VR, that is the voltage across the resistor. Okay, this is the voltage across the resistor. This is VR. This is VC is the voltage across the capacitor, and VL is the voltage across the inductor, right? Okay, now I and VR are in phase according to this diagram, and again VL will be leading and VC will be lagging. Right? What is VR? VR is equal to I into R. What is VL? VL is equal to I into XL. And what is VC is equal to I into XC. Now, if I assume that VL is greater than VC, okay, let us say VL is greater than VC. Now, how to write the voltage phasor diagram for that one? This is current I, okay. This is, I am starting from here. This is VR, right? What about this one? If VL is greater than VC, this will be what? VL minus of VC. Okay. And what about this one? This is the net voltage. Okay. VN is the net voltage of the, okay, VN. VN is the net voltage. This is VR. This is VL minus VC, and this is VN. Okay. Now, if I want to write the resistance phasor diagram, what I can write? I can write here R, because you know that VR is equal to I into R. Okay. What is VL minus VC will be equal to what? VL minus VC will be equal to what? I into XL minus of XC. Which is the resistance part here? Here for VR is equal to IR, resistance part is R. In case of VL minus VC, which is the resistance part, that is XL minus of XC, right? And what about here? We know that what is net voltage? VN is equal to I into Z. VN is equal to I into Z, which is the resistance part. This is Z. From where did we get this Z? This is the Z is nothing but the impedance. Let us say if this is the voltage source, okay, all three in series, that is R, LC or LCR, whatever it may be, okay. This is Z. This is the net voltage of the supply, AC supply. This is I, okay. According to Ohm's law, what I can write? I is equal to Vn by Z, or Vn is equal to I into Z. Vn is equal to what? I into Z here. Okay, where Z is what? Z is nothing but impedance. Z is nothing but what? Impedance of the circuit. Okay, this is the opposition offered to the flow of what? Alternating current. Z is impedance. Okay, now let us see the voltage phasor diagram. From here, what I can write? Here I can write what is the net voltage. Net voltage is given by Vn is equal to, I can use what? Pythagoras theorem. Okay, Vn is equal to what? Square root of Vr square plus of Vl minus of Vcd whole square. Okay, this is the formula to calculate what? Net voltage. This is the formula to calculate the net voltage. Now let us calculate the impedance. Impedance is given by what? Z. Okay, that is Z is equal to square root of what I can write? I can use the Pythagoras theorem. Z square is equal to the square on the hypotenuse is equal to sum of the squares on the other two sides. Z is equal to R square plus of XL minus of XCD whole square. Right, now this is what? This is the angle delta phi, and this is the angle what? Delta phi. Okay, now see the current here. The total current is I. Okay, the net voltage is where? This is N. Okay, if I observe this diagram. Okay, now this is voltage is leading by an angle. How much? Net voltage is leading by an angle what? Delta phi. Delta phi. Right. Now next, what is from here? What I can write? Tan of delta. This is the formula. Okay, for calculation, this is the net voltage. This is net voltage, and this is the Z is what? Impedance. Z is what? Impedance. Now, how to calculate? Okay, tan of delta phi. Tan of delta phi can be, if I observe the voltage phasor diagram, what is tan of delta phi? This. Okay, perpendicular by, can write base. Okay, opposite by, okay, adjacent. Understood. That is VL minus of VC by VR. If I observe voltage phasor diagram, if I observe resistance phasor diagram, the same thing can be written as what? Tan of delta phi is equal to what? Perpendicular by what? Base. That is opposite by adjacent. Okay, XL minus of XC divided by what? I can write R. Now what is power factor? Power factor can be written as what? Power factor. Power factor is given by what? Power factor is given by cos of phi is equal to cos of, okay, delta phi. Okay. Now if I observe cos of delta phi, what I can write? If I observe the voltage phasor diagram, I can write that as what? What is cos of delta phi? Adjacent by hypotenuse, that is base by hypotenuse, right? VR by, okay, what is there here? VR by Vn. If I observe the resistance phasor diagram, cos of delta phi is what? Base by hypotenuse or adjacent. This is called, okay, adjacent by hypotenuse. That is R by Z. Okay. Kindly remember these formulae. Very very important. Okay. Net voltage, impedance, and this is tan of delta phi. Okay. Now power factor is given by what? To calculate the, okay, phase difference, use this formula. Okay, phase difference tan of delta phi. Okay, but delta phi is the phase difference. Tan of delta phi is equal to VL minus VC by VR. That is equal to XL minus XC by R. Power factor is cos of delta phi is VR by Vn. That is equal to opposite. What is the average power consumed? Okay, average power consumed. Consumption of average power consumed is given by what? IRMS the whole square into R. I can write this one. That is equal to, what is IRMS? Nothing but what? VRMS by Z. Okay, the whole square into R. I can use this formula for this is what? Average power consumption. Average power consumption. Whenever you have, remember, whenever you have LCR circuit, okay, whenever you have LCR circuit, okay, the power consumption is due to what? Only R. The power consumption is due to only R, okay, not because of what? L and C. We have seen in the previous video what is the average power consumed by pure inductor is equal to 0, and average power consumed by a pure capacitor is also 0. This is the average power consumption is due to only the resistance present in the circuit. That is given by this. The hope you understood all these formulae. Now let us do one sum. Hope you understood. This is the LCR series circuit. I have drawn the circuit diagram. This is figure is, this is the circuit diagram. Okay, this is the circuit diagram. Circuit diagram. And now these are the what? Voltage phasor diagram and resistance phasor diagram. Hope you understood. Here I have explained you how to derive the formula also. Yeah, I have explained you. Now let us do one simple problem so that you can understand very clearly. Okay. Now let us do this very first problem. A capacitor of capacitance. Okay. Capacitance is given, inductor is given, and what is given? Resistance is given. Now let us write what? LCR circuit. Okay. Let us write LCR circuit. This is L, C, and R. Right. Now, what is L of L they are given? L is equal to how much? L is 2 by H. 2 by pi Henry. Okay. 2 by pi Henry. Right. Okay. That is L is equal to 2 by pi Henry. How much is C? C is nothing but how much? 100 by pi microfarad. Okay. R is how much? R is equal to 100 ohm. R is equal to 100 ohm. R is equal to 100 ohm, and it is connected to AC supply. Voltage they have given. V is equal to how much? 200 sine of 314 T minus of 15 degree they have given. Don't get scared by seeing this equation. Okay, that is equal to, I can write this as 200 sine of, okay, here pi is given, 2 by pi is given, 100 by pi is given. Therefore, I will write this as what? 100 pi T. Okay, for simplification purpose, minus of 15 degree. Okay, same thing I'm writing here. Okay, now how I got this 100 pi? We know that 3.14 is equal to what? Pi. How much is 314? 314 is nothing but 100 pi. Hope you understood this. In the previous videos also I have shown. That is equal to, okay, I can write this as what? Compare this with the equation. V is equal to what? This is V is equal to V naught sine of, okay, omega t minus of, in general, write down phi. Some angle is given. Okay, this voltage is lagging. Okay, where angle how much? 15 degree. Okay, now what they are asking us to calculate? Capacitive reactance. Okay, first one what? Capacitive reactance. Xc is equal to, what is the formula? Xc is equal to 1 by omega c. That is equal to 1 divided by, how much is omega here? Omega is equal to 100 pi. Just compare this one. Okay, compare this. Omega is how much? 100 pi. Okay, 100 pi. 100 pi into, how much is C is given? C is equal to 100 divided by pi. Micro is given. How much is micro? You know, micro is equal to what? 10 to the power of minus 6. This you have to remember. Micro is equal to into 10 to the power of minus 6. Okay. This pi gets cancelled. That is equal to 10 to the power of 6 plus 6. Once if this comes to the numerator, divided by 10 to the power of 4 here. Okay. Now I can write Xc is equal to how much? Xc is equal to 100 ohm I'm getting. Okay. 100 ohm. First one we got the answer. Okay. Capacitive reactance is nothing but what? Now let us find the inductive reactance. How to calculate XL? XL is equal to formula, we know, omega into L. How much is omega? Now, okay, omega is equal to now be omega is equal to 100 pi here. Okay, 100 pi radian per second. Understood? That is 100 pi into L is how much? L is given 2 by pi. Okay, Henry, not millihenry. Or okay, directly they have given 2 by pi Henry. Please check the okay, values what they have given. Here micro they have given. Here just Henry they have given, not millihenry. If they had given milli, I would have done 10 to the power minus 3. It is just Henry. Okay, into 2 by pi gets cancelled. That is equal to 200 ohm. So XL is equal to how much? XL is equal to 200 ohm. Which is greater? Here XL is greater than what? XC. Here also in the previous, okay, I can write the what? Here VL is given. This is also what? XL. Okay, this is what? XC. Understood. And this is what? 0 and this is I. Right. Okay, this is R. Hope you understood this one. Okay, this is what? The way how we write the resistance phasor diagram. This is voltage phasor diagram. Both of these. Okay, this understood. This is R, XL, XC because VL is greater than VC. Therefore, here also XL will be greater than XC. XL will be greater than what? XC. Okay. Here VL is greater than VC. In the same way, here if you get XL greater than XC or VL greater than VC, you'll be getting a triangle upwards. You'll be getting a triangle upwards. Hope you have understood. Right. Now, what is the third thing you have to calculate? You have to calculate the impedance. How to calculate the impedance? How to calculate the impedance? What is the formula? Otherwise, I can directly write the resistance phasor diagram. How to resistance phasor diagram? I can write this is what? This is R, right? This is what? XL minus XC and this is Z. Hope you understood. Okay, this is what? Z and this is what? XL minus XC. How much is XL minus XC? 200 minus 100 is 100. How much is R they have given? R they have given how much? R they have given 100 they have given. Okay, 100. Okay, this is delta phi. Okay, this is delta phi. Use the formula Z is equal to what? Square root of R square plus XL minus XCD whole square. Okay, square R square plus XL minus XCD whole square. Understood? Z is equal to square root of 100 square plus of 100 square. Hope you understood this. See this resistance phasor diagram. XL is greater than XC. Okay, here XL is greater than XC. Therefore, I can write this what? Resistance phasor diagram. Here, how we wrote in case of. Okay, see how we wrote here. In the same way, we are writing the. Hope you understood this. Okay, when XL is greater than XC, this is R, this is XL minus XC, this is Z. Z is equal to formula. This is the impedance we are calculating. Hope you understood this. Okay, now how to calculate this one? That is equal to whenever you have of this type 100 the whole square, you take 1 plus 1. I can write if you take 100 whole square outside 100 root 2 ohm. Okay, what is unit of all these are what? What is XL, XC and Z? This is resistance. Unit of resistance is what? Ohm. Here also ohm and here also ohm. Hope you understood. Next, what they are asking? Number 4 is power factor. What is the formula for power factor? Number 4 is what they are asking. Power factor is equal to what? Power factor is equal to what? Cos of delta phi. Okay, how much is cos of delta phi? I can use this what? 100 by 100. Cos of delta phi is equal to what? How much is Z we got? Z we got is equal to 100 root 2 pi. Okay, what is the formula for cos of? Just now we wrote R by Z. How much is R? 100 divided by Z is how much? 100. That is equal to 1 by root 2. You can stop it here. 1 by root 2. Okay. If you are interested, you can write this as what? 0.707. Okay, that is not a problem. Otherwise, you can stop here. After power factor, what you have to calculate? Peak value of current. You have to calculate what? Peak value of current. How to calculate peak value of current? What is I naught is equal to V naught by Z. I naught is equal to V naught by Z. Understood? How much is V naught? Compare here. Okay, how much is V naught? Directly they have given. V naught is how much? 200. I can compare this one. Omega is 100 pi. Pi is 15 degree. Okay, V naught is 200. 200 divided by, okay, how much is Z? Just we calculated. 100, that is equal to 0, 0 gets cancelled. 2 by root 2. I naught will be how much? I naught will be 2 by root 2. How to simplify 2 by root 2? Root 2 into root 2 by root 2. Right? That is equal to root 2 amperes. Okay, root 2 amperes. Power factor is 0.707 and I naught is root 2 amperes. What else you have to calculate? Equation of current. Okay, equation of current we have to calculate. How to calculate equation of current? Equation of current number 6. Okay. Now here, which is leading? Okay, now this is equation of current. I will show you here. I is equal to what? Here, in case of when this is I, okay, this is what? VR, right? This is VR. This is what? When VL is greater than VC, this is 0. Okay, now delta phi, right? This is what? VL minus VC, and this is VN. This is the net voltage. That is given by I into Z, and what is VR is given by I into R, and what is VR minus VC? I into XL minus of XC. This we have seen. Okay, XL minus of XC. Now, which is lagging, which is leading here? This is the total current, and this is the total net voltage. Okay, total net voltage. This is delta phi. Now here, see what is the equation they have given for voltage. They have equation. Okay, how much is the net voltage they have given? That is, this connected to your supply. 200 sine of 314t. Here they have given 200 sine of 314t minus of 15 degree. Okay, that will write on here. Equal to 200, right? 200 sine of 314t minus of 15 degree. Okay, now I is lagging when angle how much? Delta phi. Therefore, what is the equation of this one? Okay, I will be equal to what? This is V is equal to what? V naught sine of omega t minus of phi. This is okay. Now, what is I is equal to? I will be equal to I naught sine of omega t minus phi, same as this one. Okay, but it is lagging by an angle how much? It is lagging by an I is lagging by an angle minus of delta phi, right? Okay, that is nothing but I is equal to, okay, I naught. Just now we calculated how much is I naught. I naught is how much? I naught is root 2 amperes. I can write that as root 2 sine of, okay, sine of omega t is, that is same as this one, 340. Okay, whatever is there here, same thing you write, minus 15 degree minus of how much is delta phi? Delta phi is how much here? Okay, cos of how much is delta phi? Delta phi is nothing but, I'm going to get here how much, how to calculate delta phi. I have told you tan of delta phi. Okay, tan of delta phi is equal to what? XL minus XC by R. How much is XL minus XC? XL minus XC is how much here? 100. R is how much? 100. Right? 100 by 100. 100 by 100 is equal to how much? That is equal to 1. Therefore, delta phi will be equal to what? How many degrees? 45 degrees. Tan inverse of 1 is 45 degrees. Okay. Use tan of delta phi for calculation. This is the phase difference. This is the phase difference between what? Phase difference between V and net voltage and total current. Okay, minus of, okay, 45 degree. Now I can write this as what? I is equal to root 2 sine of what? 314t minus of 60 degree. I can write this as minus of 60 degree. Now, what is the next thing we are supposed to calculate? Average power consumption. Okay, this is very easy. How to calculate the average power consumption? What is the formula for calculation of average power consumption? Number 7, IRMS the whole square into R. Okay, how to calculate IRMS? I naught by root 2 the whole square into R. Right. How much is I naught here? Just now we calculated I naught is equal to root 2. I naught is equal to how much? Root 2. Right. Okay. Root 2 by root 2 the whole square into R is how much? 100 is given. Right. Therefore, R is representation root 2 by root 2 is 1 the whole square into 100 is 100 watts is the right answer. Students, hope you understood this. This is the concept of what? This is the concept of what? LCR series circuit with its one problem, so that you can understand very clearly. Hope you understood this LCR series circuit. I have taught you the concept, okay, and one problem, okay, one detailed problem we have solved. Okay, if you like this video, kindly share with your friends, subscribe for my channel, ask doubts in the comment box. Do not forget to subscribe it. I'll be coming with lot of interesting problems in another topics and in another chapters also, so that you can prepare well and get good rank in KCET as well as NEET examinations. I wish you all the best. Study well, keep studying, get motivated. Thank you one and all.